In the figure below, points A and B are on opposite banks from a small stream. Point C is on the same bank of the stream as point B and approximately 18 meters from B. So this distance, 18 meters, is this distance right here. And here's point A. The measure of CBA is 45 degrees. And so CBA is over here. If we go from C to B to A, is this angle. And the measure of BCA is 60 degrees. So if we go from B to C to A, that's this angle right here, is 60 degrees, just as they've drawn it. That's nice. Which of the following expression gives the approximate distance in meters between point A and point B? So they're talking about this distance, which they've labeled with a question mark. How long is this distance in red? All right, now they give a really important equation down below, which makes this problem easy to solve if we understand what the equation means. And so to do this, let's try to draw out exactly what they're saying here. They're saying for a triangle defined by the points P, Q, and R. So here I'm going to draw a triangle, and I'm going to label it with points P, Q, and R, where little p, little q, and little r are the lengths of the side opposite from angle P, angle Q, and angle R. So what they mean is that here I have angle P, and across from angle P, I have a side, and the distance of that side is called little p. And similarly, I have an angle called angle Q, and across from angle Q is little q. And there's also a little r. I'll let you figure out where that is. Then they say the sine of angle P divided by the length of little p. So that is this guy here, sine of P divided by the length of little p is equal to the sine of Q divided by the length of little q. And the same thing with the sine of R. So they're saying for any triangle, it doesn't matter if it's P, Q, and R, or A, B, and C, if you take the sine of an angle divided by the length of the angle across from it, it's always a fixed ratio. All right, so let's see if we can apply this rule that they gave us to this particular diagram that we have. And in particular, one thing that they're saying is that the sine, let's choose, for instance, angle A here. So the sine of angle A, which we have not determined what it is yet, divided by the length across from angle A, so that would be little a, or we actually know its value here is 18, is equal to the sine of any other angle divided by the length of the side across from it. So for another angle, let's go ahead and pick angle C here. So the sine of angle C is 60 degrees, divided by the length across from it, which we actually don't know. This is what we're trying to figure out. So this would be really cool if we can just figure out what angle A is here. Then we only have one unknown left, and we should be able to solve for it. So the length of angle A is actually easy to find because all the angles in a triangle should sum up to 180 degrees. That is, 180 should always be equal to angle A plus angle B plus angle C. So we have angle A we don't know, but the other two we do. So angle A plus 60 plus 45. And then if we go ahead and do the arithmetic here, we have 180 minus 60. If we subtract 60 from that, that becomes 120. If we subtract another 45 from that, that becomes 75. So angle A is equal to 75 degrees. That's great. Now we can replace it in our equation here, and I'll go ahead and kind of scribble it out here because I don't have that much room left. Now we only have one unknown thing, our question mark. So let's solve for it. Let's multiply both sides times question mark. So I have question mark times the sine of 75. Here, I'll just write this out in black. Sine of 75 degrees divided by 18 is equal to the sine of 60 degrees. And if I go ahead and multiply both sides by 18, this will go over here. And now I can divide both sides by the sine of 75 divided by the sine of 75. And now I have the correct answer. The distance from A to B is equal to the sine of 60 times 18 divided by the sine of 75, E.